All right, looks like everyone's here, so let's get started. This is lecture 5, basic user accounts and login sessions. So this is a pretty exciting lecture because this is actually the end of the first module of the course. You're gonna have a little bit of the second module before our test. I'll go over the details. But basically the first half, third, I guess, of the lectures was this theme called, if you go to the schedule website, it was called this Web 1.0, Web Pages and Documents. And this spans the time from around 1990, around when the web was invented, until about 2004, about when Facebook came out, actually. So in this first phase, web pages are simply documents that you just create either by hand, writing HTML and CSS, or you have a script on the server generate a document for you. That's pretty much what the web was until around 2004. So lecture 1, we covered the HTML, CSS, and then we did web servers, we did the scripting, we did the data storage and database last time, and this is the 5th lecture with user accounts and sessions. This will be the end of the first module, and the second module will be this thing which we call websites as applications, which is kind of known in the buzzword in the community as Web 2.0, which is already an old word by now. It's like 10 years old. But this is around, I would say, 2004 to 2010-ish. And we'll start finally covering JavaScript a bit, because some of you might have been wondering, when are we going to do some JavaScript? So that'll be in the start of the second module. We're going to have 2 lectures related to JavaScript stuff, and then we're going to have a break, and then we'll have the first exam, which covers the first 7 lectures. So it's kind of halfway in that module. And then after the exam, we're going to go over a few more lectures, and then whatever Web 3.0 thing I made up. It's kind of the more modern web, which is, I would say, these are all rough days, like 2010 to the present day. So this is the last phase of the class that will be kind of the most modern technologies that you'll see. So we are still at a history lesson at this point. So the cool thing is, after these 5 lectures that we just did, and all these readings, if you internalize the readings in the code, you should actually be able to, make like whatever was the first version of Facebook. So I don't know if any of y'all remember Facebook when it was called thefacebook.com. Did anyone actually remember this? Okay, maybe not. Wow. Okay, that was when I was in college. So it was called thefacebook.com. It was this really awkward name. But yeah, that was its name for the first 3-4 years when it started getting bigger, and they finally shortened it, which was probably a good decision. But yeah, that was the first thing that was released in around 2004, and this is what the site looked like. This is 2005-ish, when they already had millions of users. But basically, it looks like the kinds of sites that you'll be able to make with all the technologies you learn just in 5 lectures. So that's a learning objective for today, that if you squint hard enough at the at the examples that we put, it's conceptually the same thing as the original Facebook site. Obviously, they have a lot more fancy features and graphics and everything, but the core technology is exactly the same. So it requires you to store and load persistent data on the server, which we did last time. So you have to upload your profile photo and store it, and upload your all your personal information and store it in some database in the server. And the thing that we're going to learn this time, that's the next step, is this user accounts and login. Because basically any site you're going to need to log into as you, and we don't know how to do that yet. And so by the end of this lecture, you should actually have all the stuff you need to build something like this. So a bit of logistics, I posted this on Piazza, but all the lecture stuff, the code is all on this GitHub repository now that I created. And if you need introduction, there's videos and there's other sorts of stuff online. So the nice thing is you can actually just look at the code online if you just want to read it and understand it. So you can actually just, this is the actual code you can look at. If you want to run it, it's a little more complicated because it depends on if you have Windows or Mac. But I did make some videos over the weekend of just kind of setting up from scratch for Windows and Mac. And I have office hours tomorrow, or usually Wednesdays at 4. I have Wednesdays at 4, so if you follow these tutorials and you're still stuck on something, just come talk to me. But definitely follow these first, because we don't have time for, because this takes an hour to install. So we don't have time to go over the whole hour in office hours. And in terms of what's going to be an exam, people had questions about code and stuff, and it's basically, you need to be able to kind of, because the code is part of lecture, and you've seen it in lecture and you see it on GitHub here, you have to kind of understand what's going on here, right? I'm not going to make you write a bunch of code, write 50 lines of Python and make sure it compiles and everything is right and it runs, right? That's not fair for a test. But some of the stuff will have some light code in it because we have to communicate somehow, right? I can't just write everything in English. So you have to sort of be able to understand how it works. I won't be testing like Python details, but like you have to know like, what like that does, right? Just print something, right? You have to at least know kind of the basics and squinting around. But so definitely study the code for your exams to kind of get a sense of what this how it works. If you can run it, it's even better, right? Because if you can run the code, then you can modify it yourself and print out more stuff. But even if you've been paying attention in lecture and you're just looking at the code, you should be able to, at a conceptual level, get what's going on. So this is what lecture 3. So just a quick review. The idea here is that you're printing this HTTP header because you need to print it, and then you're printing like a HTML web page, and you're grabbing this stuff out of the either the get or the post, like the get and the URL and stuff. So like that's the level of stuff you need to know. But I wouldn't be like, here's a blank page, write me the exact code to do that without any syntax errors, because that's what we have computers for. So go check that out if you haven't yet. And let's go to last time. Okay, so last time we learned about how a file, or more commonly a database, so we use SQLite as a database, but you could use anything for your project, allows your web app to store persistent data, right? So you need to, if you want to upload your picture or your name or birthday and stuff, you need to get it on the server somehow. So you send it to the server, and then it stores it in some database or file, and then when you go to that website again, you can get that data back. So that's a way to, on Facebook, for example, you can upload all the stuff and you can get it back. This time, I always like having this cartoon up here. This time we're going to talk about cookies. So the outline here is we're going to first go over this idea that you've been reading in your readings, that HTTP is stateless and what that means. And then we're going to introduce how you can put state in. So this idea behind HTTP being stateless is pretty fundamental to how the internet, basically, and the web works. So recall our cartoonish picture here, where we have a laptop here. Yeah, maybe we have someone else's laptop. There's someone else's laptop. Ooh, squish laptop. We have some internet, and then we have a server. And then when you make a request, this is using the HTTP protocol. And then the server does something, runs some code, gives you back another thing, also using HTTP protocol. So using this protocol, they send you back an HTML web page. So very important distinction. So you should know for the exam, what the difference between HTML and HTTP is. Even though they sound similar, they're very different things. So, this gets sent back a JPEG image, this gets sent back a movie file or whatever, all through this protocol. And this other person's going to the website, doing something, sending stuff back. Now, what's implicit in this picture and what they mean by HTTP being stateless is that the server doesn't know who is actually making these requests, right? So if you made a request and then it gave you a response, and then you make a second request for something different and it gave you a response, if the server isn't doing anything special, it doesn't know whether you're the same person doing that or if you're just another laptop making a request. Like there's no real way for it to know that without it using any extra information, right? So as far as the server knows, by default with HTTP, you're just giving it some URL. You're giving it some web address, / blah 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 / blah blah dot, HTML or something. It's just fetching that thing for you and giving it back to you, and that's it. Like that's all that it cares about doing, and that's fine for the simple sorts of apps that we've been building. So this is be stateless. So this is fine for, say, say this, right? So a static web page would be good. So let me copy this. What did we call this? Lecture 1 HTML. So if you're just fetching the web page, it's an HTML file straight up, that's fine because it doesn't need to know who you are. It just says, somebody wants this HTML file, I'm going to give it to you. Somebody else on another laptop wants, I'm going to give it to you. That's all good. Even if you're running a script, it's okay because paste this in. You're passing in all the parameters in the URL itself or in a form. So this is asking for this resource and it's passing in all this information. And then the server processes it and gives me back this web page. That's fine. I can send this URL to anybody else, like to all of you, and well, not on my server, it's on my computer. But if this is on a public internet, anybody can visit that URL and see that exact same page, right? And that's what it means for it to be stateless. It doesn't know who you are. Obviously, I can change my name and stuff here. I can change my name, and then this is good. So this is okay. So you can imagine building Facebook this way, because what you can do is imagine if you're on Facebook, I mean, this is obviously not logged in, but oops. So imagine this won't actually work, right? Imagine facebook.com and then you say profile.html. I'm just making this up. And then username equals John or something, right? Like this could work, right? Because this doesn't work because not how the site is, but you can imagine if when Facebook sees that you put in the username variable as John, it will just go in and grab all of John's info and print it out to the page, and that's cool. And then if you want somebody else's info and you want to, you want to log into somebody else, you can do that. So that's basically so far one of the only ways that it can tell who you are, right? But so what are some problems with just doing this way? Yeah. Okay, so security is a problem. Anyone can see anybody's stuff. That's good. That's a good problem or a bad problem.
It's likely that there's multiple users named Philip.
Yep, that's good too. So we can get rid of that by having a unique ID, right? So everyone has a Facebook ID that's some number. So that will get rid of that. You have some number, but then you can't remember it. That's another problem. Yeah, so it's security. It's inconvenient. It's kind of it's good in the sense that you can give anyone a link. So it's good for public things, right? It's like if you have a public photo gallery and it's just whatever flickr.com or whatever Google Photos / your username / and that's okay because you want everyone to see it. But obviously, what you really want on Facebook is this, right? You want, when something magical happens, you want to when you go to facebook.com, whatever profile, when I go to my computer, I want to see my profile. And when you go on your computer, you want to see your profile, right? So that already is breaking this statelessness, we call it, from the internet. So the idea behind the HTTP being stateless is that when you have a server, if I asks for facebook.com / profile, whatever, and this other person asks for facebook.com profile, it's the exact same URL. So the server doesn't know who's who, so it has to give us both the exact same page. Or else it doesn't make sense that it's, what does that URL mean? But when we want to introduce some state, we want to say that something happens. So when I visit facebook.com / profile, I get my own profile info. And when John visits it, John gets John's profile info, right? So we both can visit the exact same website and see something different. So the way this works, this can work in many ways, but one of the ways that's most common is using what's called cookies. So how many of you have heard of the term cookies in web browsers? Good. So anyone who's used a web browser might have seen pop-ups or seen disabling cookies and stuff. So this lecture we will just demystify what these cookie things are. And it's actually, if you look in the readings, they're actually really small and simple things. They're not like these mysterious viruses or whatever people think they are. They're just little bits of info. In theory, in this conceptually, we need something that identifies this connection as Philip's and this connection as John's. We could put it in the URL, right? If we say name equals Philip and name equals John, that identifies us. But then we have two different URLs now, right? So then it's like we're visiting two different pages. We want to visit the exact same page. Okay, so introducing state with cookies. So I'm going to talk about the concept of cookies super abstractly, and then we're going to just go into the code. So let's erase our messy picture here. All right, I'm just going to start over. Okay, so one computer, internet, one server somewhere. Okay, so what we do now is, let's say the server, I'm gonna start building up my code for my notes. If cookie string. Well, let's actually start building up the code first, and I'll switch back to this picture. It makes more sense with the code. Okay, so I just started, this is not uploaded yet, but I just started a new piece of code called Lecture 5 Cookie Tests. Okay, so this is just on my computer. You can't see it yet. This is called Lecture 5 Cookie Test.py. I just reloaded. I just printed hello world just to make sure the script runs, and I have all the permissions. So it runs, and let's start editing the code. Okay, so if we look at this, is just this is on Windows. On Mac, you need another line. We'll put again all this code up later. We import the CGI module, and we just print content type HTML and just print hello world. That's why when we go to here, we reload, Control R, we see hello world. Okay, so let's start. I'm just going to start writing the code in and see what's going on. So the first thing I want to do is just have some data. Like this could be anything. So we're going to use dates again, just because it's something that's unique. So import date time. This is a Python module. We're going to have t, which is the current time, is date time. This is what we use for the first lecture also. Should have a syntax here. This function or method returns the current time. str in Python just converts it to a string, so it's like print it nicely, and t just stores it as a variable. So just a sanity check, let's print hello world and then print t. So we're going to save and reload, and it should print out the current time when we're, this is from second or third lecture. Okay, so this makes sense, right? So every time I reload the page, it will print out the current time. It'll get it from the server and it'll just print it out there. Okay, so this is lecture 2 or 3. And then it changes, obviously, every time we reload. Okay, so we're going to, now we have t working. We're going to import some more fun stuff. So we're going to import cookie with a capital C and OS, which is the operating system module. This is, again, code that we provided. So usually, if you look in your readings, all a cookie is just something you set in the header, in your HTTP header, which is here, right? So this is the HTTP header. All it is just some tag you put in the header. You can write it manually. You can just write your cookie manually, just something, colon, something. But most languages you work with on the server, Python, Ruby, PHP, whatever you're going to work with in your project, they probably have some library to do this so that you don't have to write it manually and have typos and stuff. So the Python library is just called cookie with a capital C. And there's just some interfaces that you can look up for working with it. So here's one we're going to use. We're going to do a check first. Let me make sure this works again. Oops. No. So reload. OK, so the first thing we're going to do is we're going to, let's do this. Hello, the current time is, I'm sending a cookie. Let's do print C. OK, so let's create a new cookie. So let's do this. So C, just a variable, equals new cookie, which is called cookie.simpleCookie. And this is a constructor for an object. So this is the library function, all the code we provided, for creating a new cookie object in Python. All right, so here's a cookie object, and then we're assigned to C. Now we need to set something in the cookie. We need to set some key and value. So we're going to use a similar syntax as a dictionary. So we're going to set current_time equals t, the current time. So if you're not familiar with Python syntax, this is saying, C is some object. We're going to set some key in it, which is called current time, which is a string. This could be anything. I just call it current_time. And we're going to set the value to t. So this cookie inherently represents one piece of data, which is current_time is mapped to whatever that string is that I produced. OK, so what do we do with this cookie? So we need to send it to the user. So we send it to the user by simply, we simply just print it out in the header. So what we do is we just print C. So this line actually has a lot going on in it that the library hides from us, because C is some object, right? This is some like cookie, like, yes, question?
Why do you need the current time in the brackets? What is that at? When will you use that, either in code or in a form or on the website?
Here?
Yeah.
Oh, we're going to use it because a cookie conceptually stores some binding, right? It stores current time in ours, lines to, I don't know, 7 p.m. or something like that. So we're gonna, you'll see how we're gonna use this in a second. We could call something else if you don't like current time, but it needs to be called something. Other questions? Yes?
So cookie essentially just stores information about the user?
Yeah, it stores information. Yeah, basically that's what it is. You can store a lot of information, but usually a cookie stores just one piece of information. And it stores it, so, yes?
Oh, I was just going to ask where it stores it. I know it stores it
Mm-hmm. Yeah, so this is a good question. Where is it storing it? We will get to that as we move on to an example, but hold that question. If I don't answer in 2 minutes, then you can ask it again. Good. So some information that's being stored. Right now, it's not stored anywhere. Right now, as the code I'm writing, it's just on the server right now, right? I just created something, and once the script ends, it's gone. So we need to store it somewhere, right? So what the server does, if you remember from your readings, is it just prints the header, which is the regular header, and it does print C. So what this piece of magic thing does is that all Python objects know how to be printed. So when the C object, when this cookie object is, someone calls print on it, it knows to convert this cookie into like the right format, like it's called set cookie : whatever. It knows to do all the right things to print it as a valid header so that you don't have to worry about the syntax. And we'll see exactly what this means. And now I'm just gonna print, I guess, let's just make it a little fancier looking. Sure, let's just make it fancier looking just for completeness. HTML, body, it's not super interesting code. Print h2, hello, the current time is, oops, plus t plus h2, and then also print h2, I am now sending, oops, I need the quotes. I am sending you a cookie. Okay, I think that is it, and then we don't need T anymore. Okay, so, we need to end the HTML. Body. This is very sloppy HTML, but if you squint at it, it works. Okay, so what this will do is this will print the exact same kind of web page. I just say, hello, the current time is whatever. Now, the only extra thing here is that there's a C thing in the header. So if we go to the page and reload, it just seems to do the exact same thing. I mean, with some HTML, it just looks like it. It says, I'm sending you a cookie. Now, you don't see the cookie anywhere on the page, right? It's not like it's on the page. And it's because it's in the header. It's here in the header and not in the page. So if we use our trusty command line tool, curl, and visit this URL. So what is this URL? This is lecture 5 cookie test. I'm going to copy it. And if we use the command line tool curl and we visit it, so we do curl -I and then, how did I paste? Paste. So I'm just going to visit this URL. So remember, curl is like a web browser, except it's just on the terminal. So I'm just going to visit this and see what the server gives me. So when I visit this, the server doesn't know that I'm using this command line thing. It thinks I'm a web browser. So I press enter. Let's see what it gives me. This, recall, is the server responding to the browser. So we just did, go back to this picture. We just did this, which is just an ordinary HTTP request. And now the server does something now. The server will respond. And this is what we're reading right now. We are reading the text of the server's response. So this is the server's response right now, and this is it. It's these, 10 lines. That's all the server is giving us. So what does it say? It has the header, and then it has a body. So the body is easy, right? You all recognize the body. This is the HTML web page it's giving back to us. Current time is blah, blah, I'm sending you a cookie. The header has all the usual responses, date, everything. But if you look at here, this is the new thing right here, right? I'm gonna make the red thing bigger. This is the new line right here that it's sending. So it says set cookie : current time equals that. So I hope that answers the question about where the current time is. It's in this header that the server is sending back to you. So it's the server sends back data, and this data in HTTP contains the cookie in the header. Does that make sense? So the server's not storing anything right now. It's just generating something, and in the payload here in the HTTP, there is some cookie thing. And all the cookie thing is just one line right here. It's actually very tiny. It's just a line of stuff. Yes? Good. Very good question. So what happens now, right? So we're gonna get the response, and curl doesn't do anything with it because it's not that smart. It just prints it out. But if you're actually in the web browser and we do this, something happens. Web browsers know how to store cookies. So it is being stored, I guess the answer is it's being stored in your browser, which is also in your computer, right? It's being stored in your browser, which is part of your computer. So to look where it is, you can do inspect element to go to these developer tools. And there's a thing called resources right here. And resources, lo and behold, there's a cookies. Oh, this icon is cool. There's a cookies icon, you see? It's a cookies icon. There's a bunch of other stuff too that we'll learn, local and session storage and some lecture down the line. But cookies, if you go in, These are the cookies for localhost, because the cookies are per domain, right? If you remember from the readings. When you're on your web browser now, like if you open your preferences, you probably see a ton of cookies from all the sites you're logged into, Twitter, Facebook, Google, whatever. There's a bunch of cookies for every site. So if you think about the permissions, like the site can only see their own cookies, right? It would be bad for Google to see your Facebook cookies. They can spy on you. So localhost is my own site I'm running right now. It's on my computer. If you look here, it's actually being stored in your browser. So current time is indeed 17:15:56. It's indeed whatever we printed out. So the answer to your question was, when the browser gets it, it stores it in itself somewhere in memory. So it's stored in the browser here, which is in your computer. So I'll get into later how there are two types of cookies. So by default, the cookies are stored in RAM or memory. So then when you close your browser, it's gone. All right, but then there's another kind of cookie called persistent cookie. So if you actually set an expires tag on it, then it'll actually tell the browser to store it on the hard drive. So then that's how on Facebook or Google, you can close your browser, close your computer, open it again, open your browser, and still have that cookies there. So there's two types. Yep.
Is that basically like, you can go on Google Chrome and hit clear cache, and when it gets rid of all your passwords and all your account information, it erases those persistent cookies?
Yeah, so so there's Google, I think most browsers have a clear like everything, right? It's like, I was really shady, so I'm gonna clear everything. And that includes the cache, which is just data that's stored, passwords, cookies, and everything. You can just clear cookies themselves, so yeah.
So what would a cookie that is stored in the RAM and thus deleted every time you close an application or your computer, what's that good for?
Yeah, what's that good for? Yeah, so what is a cookie that is only in RAM good for? One way is, if you notice how some websites have like that's the best example, but some websites have like a remember me after this, or I'm on like a public terminal, I'm like at the airport or at the Starbucks. So if you're at if you're in a computer lab in a public computer, then it's nice to have it not remember, because then when you close your browser, your login is all gone. So that's nice. So if you're on a public computer, you don't want it to stay. There are some temporary things that are like, I'm trying to think, shopping carts you might want to persist, maybe not. Or like if you're like shopping on Amazon, maybe you want to keep it after you close it. Maybe it's just you've been playing with the site on a few pages and you don't care about keeping it. So yeah, I mean, there's two ways, but most of them you keep, yeah.
So if you're on a public computer, why would you want to save the information at all? Or why would it save the information in the first place?
Why would it? Well, so if you're on a public computer and you're like, and you really need to check your email or whatever, you can log into Google and just say, don't save my persistent thing. So when you close your browser and you open it again, you're not logged in. So it's up to you. I mean, it's up to the site what they implement. Usually using public computers isn't super safe anyway, so you just gotta be careful. Yeah.
So how do they secure the cookies? Would it be, do the companies themselves tag the cookie with whatever, and how does that, I think they tag them, how does that work?
Yeah, so the second reading you did has some introduction to all these session IDs and stuff. We won't go into, part of this class, we won't go into security, so we won't need you to be like, how do you make this really secure system? But it can get pretty hairy, right? Because by default, these cookies are not secure at all. HTTP just goes through the internet. Anybody can like sniff all your packets and see all your cookies. So the first step is you use something called HTTPS, which is all the secure sites should have. Well, clearly not mine, but on GitHub, yeah. So all these sites mostly use what's called HTTPS. So in that case, your net traffic at least is encrypted, so the cookies are encrypted. But then still, if someone, say, takes your cookie or takes it, they can still impersonate you. So the security is a big issue. The second reading goes into a little bit, but the short answer is it's complicated and it's hard to do right. And that's why there's always security problems. So there's not like an out-of-the-box solution that's like great. Other cookie questions? So we're on our browser. Yes?
Why the name cookie?
Why the name cookie? I was prepared for all this. It came from this thing called a magic cookie, which is an old term used in old computing systems, even before the web, for just basically meaning if you're connecting to a server, like in the really old days before the web, you need to send some bit of information to identify yourself. So they just called it a cookie for some reason. I don't know why. And then the web standards people just took that same term. Yeah.
So I guess I don't really understand the example because if you send a password, could you use the server and then send out information without using a cookie or
Without using a cookie or not?
without using
Without using a cookie. Would you want to do that or not want to do that?
I'm asking why would you use it?
Okay, why use a cookie? Okay, so let's say you have the username password thing, right? So let's say, for the purpose of security, let's say it's all secure. You have a website. doing my terrible UI mockups here. So name, actually I'm gonna draw on the left. So let's say I have a website, name, password. Okay, so you send it to the server, and some secure means you send the name and password to the server, right? The server goes, good, you know, you're good. We're gonna give you the page, right? We're gonna go back and give you, like, here is your Facebook page. Like, we're good, right? And there's no cookies involved, we're good. Now, you can visit this page as you, that's great. But as soon as you reload the page or go to another page, you have to enter your name and password again. Because how does, if I go to, let's say I go to Facebook profile. Now let's say I want to go to Facebook / I don't know, like my photos or something. These are terrible URLs, .html. So I log into Facebook, I'm good. That first page I'm good, right? We don't need a cookie because I authenticated, gave me the first page. Okay, so now I'm gonna click and say I want to see my photos. Now we're stuck again because Facebook doesn't know who I am. It just thinks I'm some random person. So you can, every time you go to Facebook, the next page, you can enter your password and username again. That's all good. You can do that if you want, but that's super annoying, right? You can enter it again, or you can put it in the URL, which has security problems. Does that make sense? And in fact, for security, some people make you do that. So on Amazon, before you buy something, it makes you enter your password again. That's an extra security. Question?
So cookies stores users' information, so it is a type of file, or?
It's not necessarily a file. You just think of it as a string. It's just a string. And it can be stored in RAM by default, right? But it can also be stored in a file. So for example, the persistent cookies, when you close your browser, it needs to be stored in some file. So that's some file somewhere. And that's why if someone steals your computer, they can get all your cookies, because they're just files. Yes? Do you have a question back there, or you're good? Questions? Yeah?
Yeah, how does server read its own cookies?
Sorry?
How does the server read its own cookies?
How does the server read cookies?
They, like interpret the cookies that someone is like.
Good. Let's do, we'll do that in the next phase. Yeah, so we're now back to the browser. We're going to go back to the server. Do you have a question there, or we're good? So we're in the browser. So we're going to just hold that for 1 second. We're going to go back to the server. Okay, so we are now in the browser, and something happened. Yes, that's right. So the browser now has a cookie. So this cookie here, localhost, this is stored in the browser. This happened that if I close the window, it'll go away, but it's there. So now what happens when I reload the page? When I reload the page, what happens is the following. Let's go to network. I'm going to reload. This thing again. The font is giant. Okay. When I reload the page, what does that mean I'm doing? I'm going to go here. This is the second time I'm loading, right? So the first time, I'm just going to redraw this picture again so it's less messy. Load number 1. This is why we call cookies introducing state, right? Because if there's no state, it doesn't matter how many times I reload it. The picture is really simple to draw. It's just this and this. That's all the picture is. But now our picture has to be a little bit more complicated because there's a time dimension. So to reanimate, once again, the first time we go, we make a request, server does something, it sends us back a cookie, and then we put this cookie on our computer, or in the browser, okay? Now the second time I go to the same page or another page on that website, like on Facebook or whatever, the second time I go, the first time I go, I don't have anything. The second time I go, I'm gonna draw this picture down here. The second time I go, I actually take my cookie and I send it to the server. So that's how you get, I think there's a question here, that's how you get the cookie back to the server. And that's automatic, the browser does that. So if you already have a cookie and you visit the same page again, or the similar page on the same domain, your HTTP request automatically puts the cookie in your request. And then now the server can, like your question, it can do whatever it wants with it because it knows there's a cookie there. So I just want to show how it actually does that. So remember the second request, we put a cookie in here. The first one, there's no cookie. Okay, so let's see the second request. Well, all subsequent requests has a cookie because I already have it. So if I view this, the headers, this is gonna be hard to read. I gotta squint here. This console is terrible. Down. So the request header. So this is the request of me sending to the server. If you look down here, there's a cookie right here. And this is just called cookie. And that's the cookie I stored. It's just that data. So that bit of information in the header is is this thing being sent with a cookie inside. Make sense? So to show that there's no tricks, if being a magician here, I'm going to show the first send again. And to do the first send, all I do is I erase the cookie. So where is the cookie? Let's erase it. It's just in your browser, you erase, so no cookies. We erased it. Now when I do the request, abracadabra, I do the request. I go here. Ah! Oh no, what just happened? Okay, I go here and I go to the request. And notice how there's no cookie here. There's a bunch of stuff in my request, but there's no cookie. Request header, there's no cookie because it's my first time. But then if I do the second time, I should see a cookie right here. Right, and all the other times there should be a cookie right there. Yes?
So you can have multiple cookies, right? So
Yeah.
this is just like for this particular cookie, this is what's going to store it and just leave it alone.
Yeah, so every site you go to, every domain, what's it called? This is a domain, right? Localhost or Facebook, whatever. Every domain can store like, I don't know, 100 or however many 100 cookies. So yeah, so the server can send you however many cookies at once. The easiest way to think of a cookie is every cookie is just one name value. So if they want to send you 100 pieces a day, just send you 100 cookies. So yeah, you can send as many as you want. And it will send all of them that are relevant. So you don't choose which one to send, yeah?
I was going to ask, does the browser send all cookies associated with that domain each request?
Yes. So the question is, which one does it send? There are rules you set on the cookie, basically how you want to partition it. But in general, if you don't set any rules, it will send all the cookies with the domain. So for example, if you're on Facebook, whatever page on Facebook you're on, this is how you can navigate multiple pages, right? You're on Facebook home, then you go Facebook/ edit pictures, Facebook/ post picture, Facebook/ whatever your friend's profile. Every time you go visit Facebook on Facebook.com, it will send all your Facebook cookies. It won't send your Google cookies because it can't access them. But you can set options to limit it and stuff. But by default, it sends all of them. Cool. Okay, so we send our awesome simple cookie to the server. So now we're back on this picture here. So first time, get a cookie back. Now all other times we send it to the server. Now the server needs to, like your question there, the server needs to do something with the cookie. By default, the server doesn't do anything, right? So right now, that's why our web page right now looks pretty, I can reload this all I want. It does the exact same thing. And it's because the server doesn't care about the cookie right now. It doesn't know it exists. It doesn't do anything. It just doesn't handle the cookie at all. And it just, no matter what happens, it just prints out, hello, I'm going to send you a cookie, and just sends you a cookie back. So now conceptually, we need an if statement here, right? We need on the server, if someone gave me a cookie, do something. If no one gave me a cookie, do something else. So we want to have different behavior based on whether to get the cookie back and what the value of it is. So to do that, we will look at my code here. So we will first get the cookie. So this is your question. How does the server get at the cookie? You write some magical code to get the cookie, which is, in Python, it's os dot, we'll say stored cookie string equals os dot environ dot get. Okay, so for those of you who are familiar with kind of Unix-style environment variables, basically what happens is when you make a request to the server, it actually sets an environment variable, which all programs on Unix systems run in some kind of environment with a bunch of variables already set. And it sets one called http_cookie and just sets that string. So what this os.environ, if I spell it right, .get does, is it just grabs that string out if it exists on the server. So, and then it stores it into, you can call it whatever you want, you can call it X, but I call it stored cookie string. So this string is the actual content of the cookie if they sent it. If no one sent a cookie, it'll be empty. So now we can use this to write an if statement. So let's do, actually let's just print it out just to show you. Let's comment all this out and just print stored cookie string. I'm just gonna print it out just to sanity check. Okay, so I'm just gonna print it. So I'm gonna go back to my machine here, and no cookie. I'm gonna destroy the cookie. No cookies. Sad. And when I load, it should say store cookie string none. So Python none is, I guess, it's a none object. It's not actually an empty string, but it's some kind of a null value. And it's because the first time I went to the server, the very first time again, I did not send a cookie. but then the server gave me a cookie back, and the second time I did send a cookie. So I'm going to do the second run now. And when I reload and go to the server again, if you notice, that's what the server sees. Right? And it's just printing out for me. So now the server code has grabbed the cookie value in stored cookie string. And if you read this, it's exactly the same as what's stored in the browser. So this is 1731.07, and in the browser, isn't that? Did I not refresh? That's weird. It should be.
That's the
Oh, it's a new one. Yes, that's right. Because it actually sent it back. Good to your point. Because my code actually grabs it and it just sends you a new cookie. That is super confusing. Ignore that for now. Okay, so we know that stored cookie string is something. So we can just do an if statement. So if we'll say not stored cookie string. I'm doing this backwards for now, so we can. So this means if this was none or empty, like we didn't have a cookie, this means we visited the first time. This is my first time visiting this site. So my first time, it's just all the existing, it's just all the code. I'm just indenting it in Python because you need to indent inside this statement. But I'm just taking all my code from before and doing that. So that makes sense. This is the exact same code. I just put it in an if statement and say only run this code if nobody sent you a cookie. On the first time, run this code. So when I visit the site for the first time, I should run this exact same code. Just to verify, let's do this. Just to verify, let's do this. I'm going to clear the cookie here, my cookie jar, run, and it does that. I'm sending a cookie, and then I have a cookie now. What happens if I reload and run again now, given this code here? What happens if I reload the page? It's going to what? It goes blank. Good. That's a charitable explanation. It actually gives you a terrible error that you will see all the time in your project. And how come it gives you this terrible error? Sir? It didn't, yeah. There's no HTML, but that will just be blank page, right? So no HTML means blank page. So that's a good explanation. But what else is missing? Yes, not just content, everything in the header. Yeah, you're missing the header of the HTTP. Where's the header? I'm missing it. This one. You're missing that, right? So if you don't actually send back any data at all, you will get this terrible error that you can't debug. Yes?
What happens if you actually try to email admin at localhost?
That's a really good question. It's like a philosophical question. It gets to the heart of life. Well, nothing, because I'm not running an email server. But if you were to run an email server on your computer, then you should be able to email yourself. Be weird, but yeah. I mean, that email address goes to you, your server. So on your computers, if you set up an email server, you should be able to work. But that's not a great use of your time. You will waste your youth doing that. Enjoy your youth, don't do that. All right, so we clearly need to do something else. So when do an else, let's just, so what should we do? We should, first of all, let's not even send back a cookie anymore because we don't need to. So we're gonna visit us again, right? So this is all subsequent visits, so let's do this, and let's just now make sure we have a blank page. So now we have a blank page. So I'm reloading. We have a blank page because I print out the right header, it's correct, but I just don't have an HTML. So if I print here, hello, then it should just be hello, right? So I can reload this all I want. It'll keep printing hello because I have a cookie. If I delete the cookie, the first time it'll say, hey, I'm sending you a cookie, and this is the cookie, and all other times they'll just say hello. So this is just an if statement based on whether you have a cookie or not. If you have a cookie, do this. Oh, sorry, if you don't have a cookie, do this. If you have a cookie, do that. So questions on this so far? We're going to just go keep writing this code in. Yep.
So if you have 100 cookies, if you want to have a stored cookie string, do they just list them all?
Yeah, so I think you can parse it. Yeah, so basically, I think it's stored if you have 100 cookies. It's all stored in that giant string, and then you need to parse it somehow. And that cookie library will let you parse it. So we will do that right now, actually. Let's actually parse the cookie. So parse the cookie. So we need to do something with stored cookie string because, as you mentioned, it's just a string, it's just some characters. And to do that, what we're going to do is we're going to make a cookie called C equals. Actually, let me move. Sorry, I'm going to move this in so it's a little less confusing. I'm moving this code in here because we only need to do this when we don't have a cookie. So this should do the same thing. I just moved the thing in. So now we're going to have another C here. And we're going to do cookie dot simple cookie stored cookie string. So what this does is that this parse the cookie string. This will take that string that the server has, which is just a raw string, and it will create a simple cookie object from that string. So that inside the library here does all the parsing. This is why you don't want to do this by hand, because then you have to split it up and find all the data and stuff. This will give it all to you. And now this is a Python object. C is the Python object that represents this whatever cookie it sent you. So because it's an object, you can do stuff with it. So we can actually do something smart with it now. And the way we do stuff with it is we just grab the data out. So I'm just going to copy this code because this is slow. Okay, so we'll print the server received your cookie. Print your cookies. Quotes here. Your cookies current time is plus h2. Okay, so what we put in here is very similar to the form. So we do C lookup current time dot value. This was back to your question of where do you get this current time from. Now this is so the fonts are big or too small. Well, make this smaller. What we're doing now is the server has the cookie, it turns into an object, and then we're grabbing the current time thing out of that cookie. So this will give us a string that contains the cookie. So if we do that, then, and we run the code, let me save it. If we run it, so recall what's happening is now we're sending the second time, and we're sending a cookie. Now the server will say, I want to print out what the cookie is and give the thing back to users. So the second time the server doesn't actually send a cookie, because if you notice here on this response, we're just printing the header. There's no cookie here. There's no print C here. So if we actually go to the page and let's do first time again, just to make sure. Hello, the current time is this. I'm sending you a cookie, and then now the browser stored the cookie. Now when I reload, it should set the browser sends a cookie to the server reads it and prints out something. And that's what it prints out. So it says the server received your cookie, great. Your cookie's current time is didn't put a space, but is that. So questions on that? That was the second. So you need 2 round trips in order to get this to work. The first time you send it, the second time, first time the server sends it, the second time you send it back. Okay, so now you can all implement Facebook login, right? Hopefully, with all this great information. Just a few more steps. Well, except for the security thing. Let me put a space, just to make sure it's space. Okay, so then you're squinting at this and be like, all right, how is this ever useful? I am never gonna do this. Like, I'm gonna send a cookie with a date and it's gonna send it back. But now actually what we've done is the following. Now if I go to another browser tab and I go to the same site, notice that. Now actually I can open several browser tabs, and because the cookie is in my browser, every time I go, I actually am kind of logged in a way, right? Like having the date thing is actually logged in. So then it's as though I don't have to go back and start a cookie from scratch. So I'm actually going to make this a lot more concrete now with a login example. So this is state. Now we're going to spend the next, I guess, 20 minutes or so doing a user login, a really simple user login without the security part. And once you see this, you'll start seeing an idea of how you can log people into your site and keep it. So in order to do this, let's actually go to let's go back to, let me see, lecture 4. Okay, so recall from lecture 4, which is last time's, that we had a create database. So remember, we created this people.db database. In this database, we put 3 people in there. We put Philip, John, Jane. We put our ages. We put our profile pictures or whatever pictures we wanted. So, and in lecture 4, we showed how you can use your script to update this database and insert new stuff in. But we're assuming we have a database. These are all the 3 Facebook users right now, and they're their profile pictures. That's great. So what we want to do is we want to have something like have yourself log in as a person, and then after you log in, you can see your profile photo. And if you log in as somebody else, you see someone else's profile photo. And we're not going to have passwords yet. So in order to do this, we're going to, let's go make an HTML file, right? Let's just do it without the HTML. Lecture5.html. So lecture5 cookie test. Okay, so let's go from here. Let's just start modifying this example. So the way to do this is, my notes. Okay, so the way to do this is the following: is let's forget the date thing because the date looks kind of useless. Let's just have a username, like a name you pass in. So let us do. This is back to the previous lecture. Let's do field storage import CGI form equals CGI field storage. Is my name in form? Do this, else do something else. I'm just gonna exit. So I'm just gonna exit out of here so I don't run any of the code below, just so I can start afresh without erasing it. If name and form, we're gonna print. Let's just. We're starting to build a thing where we just put in your username. There's no cookie here. No cookies here. Else print. No username. I didn't even bother print HTML, but your username is plus form my name value. I think that's right. Okay. So what this will do is we're going to go back to like lecture 3, and we're just going to go to this URL. I should name it not cookie test, but we go to this URL, and if I put in my name, it'll say username is blah blah. Let's clear all these cookies first. Your username is blah blah, and then if I say John, I'll say username is John, and so forth. If I don't put in my name, it'll say no username. Oops. So that's straight up from lecture 3. So did I pass in a username? If so, good. If I didn't, too bad. Okay, so what do we do with this? So let's simulate you logging in by, we're not going to make extra form, but let's just say on a really simple version of Facebook, for some reason, since they didn't want to make a login page, you log in by just saying this, okay? Let's just pretend like that's the case. So, because I'm just, I don't want to go make another page. Can you imagine make another page, log in, press button yes, and then it goes to this page. Let's just, to log into Facebook, just pass your thing in and we're good. So, and then, John and so forth. So let's make our profile photo. Let's print HTML body. Let's just make a profile. This is clearly a really compelling version of Facebook here. So I'm going to make a profile. And then print body in the end. Body HTML. And then it'll say print your username is blah blah, or hello blah blah. Say hello, name, and okay. So now it needs to do something. It needs to get your information out. So actually, let me do this in a variable. So we'll say name equals this. So hello name, just make sure this still works. So this is your username. This isn't magical, right? We can put anybody's name in. But here's the part that requires the database, because obviously on your Facebook profile, you don't want to pass in all your data. You don't want to pass in all your profile information. It should be stored somewhere on the server. So on the server, we created a database, if you recall, that there's some entry that my name is stored with my age and my profile cat photo, right? So I should be able to grab this out of the database, which is, let's see, I have to write the SQL again. So that is for our I have to connect to the SQL code. All right, so all this code, again, you can just copy and paste because you just write it once and just copy and paste it. I got to rewrite again. So port SQLite 3. This is the database code. The connection is SQLite 3 connect people.db. That's the database. As well as con.cursor. Okay, so in order to get our data out, what we need to do is we need to query the database. So we say for row in execute. This is the SQL statement. Select star from users where name equals question mark, and put name in a list. We will tab all these things, put it in the for loop. I should just print this once, but let me print this outside. Print. Okay, so we're going to say hello name, and then we're going to say age colon plus r dot. So the second thing is the age in the database, and the third thing is the profile photo. Photo is, I just want to make sure I'm getting all this data out. So this is just querying the database straight up. And if I reload this, oh no, paper. This is an integer. More annoying Python things. Okay, so basically, I don't have the photo shown, but basically what this does is by me giving a username, it knows I'm in the database, and it looks up my age and photo, right? And if I give it John, that's John's stuff, and this is Jane's stuff. So this means my database is up and running, right? So just to make sure this is a little bit more compelling, we'll say image source equals thingy that. So we've seen all this before. So now instead of printing out the profile photo, it will do that, right? I don't like it being so big, so style equals something like that, just to make it not as giant. Okay, so this is what we had before. So this is Facebook 1.0, you know? Like, I didn't have to pass in all my info, but all right, so if I pass in my name, at least Facebook or whatever has all my data now, somewhere, right? And I can see my picture, and I can see, if I'm Jane, I can see her profile. If I'm John, see John's profile. If I put in a wrong person, it just doesn't do anything. Okay, so let's go back to here. Okay, so this is great. This is our Facebook 1.0 or 0. Whatever. And we can go log in and keep on just pasting in my name everywhere, and that will work. But ideally what we want to do is we want to just go to the terrible URL. We want to just go here without a username, right? We don't want to keep putting in our username every time, typing it in or password or whatever. And we want to actually see our cat, right? We want to keep on seeing my profile without keeping on typing in my name. So in order to do that, we need a cookie. So the cookie would be, let's see, the cookie code will be right here. All right, so this is I pass in the name first, and then the additional thing what we want to do is we want to actually send the cookie with your username now, because we need to send it back to the browser. So to do that, we will create a cookie right here. This is the first visit. First visit to the site. And now instead of current time, I'm just going to call it, I don't know, current name, just to separate from my name. Current name equals name. So again, I could call it whatever. This is the cookie, and very, very importantly, you have to print the cookie. If you don't print the cookie, we never send it back. So if we do this and it works properly, the first time I visit with the username, it's as though I'm logging in, like I type in my username, I log in, no cookies. I'm going to go here, I'm going to reload the page, and hold my breath. Ah! Oh, no. Haha. I use C twice, because I use C up here. All right, so I do CUR. It's the problem with renaming your variables. Always name your variables good things and not just one letter. Yeah, that's another thing. When you're coding, don't have one letter variable names, because this happens. Okay, so let's clear it. I'm going to reload. And now I see my page, and lo and behold, inside my browser, there is a cookie with current name set to my name. So now, if I visit the site again, so this was, recall this, so we'll do it in terms of this example here. This was, oh, cookies. This was, you're gonna get super tired of this same drawing, but this is the central concept of the class. I have to keep drawing it again. So this was, I have nothing. I send in the HTTP. It's like I logged in with whatever we're called, my name equals Philip. The server says, okay, that sounds good. You're in the database. There's a database here, like your checkout. That's great. I'm going to give you your profile page, but I'm also going to give you a cookie. And the cookie is, what is it called? Current name, Philip. I just want to name it a little different. And now I take the cookie and I put it right here. Now I have a cookie. So that's the world I'm in now. I saw my page. It's great. It looks like a wonderful cat. And then I actually have this in my browser. So when I go visit the page again, I don't need to put my name here necessarily. I don't need to put, I can put it again and it'll just do the same thing. But if I send it, go to the page again, I don't put my name in the form, then what happens is when I go again to the server, I don't put anything in the form, but because I have a cookie here, the cookie is being sent to the server. And the cookie contains my name now, right? So the name is no longer in the URL or in the form, it's in some cookie that you never see. Like you never see the cookie being sent, but it's being sent. So now the server has my cookie, and it is now, so I don't have a username here. So I'm down here on the no username field. So right now what the code should do is it should just say no username. So, you know, sorry, no username. So let's just make sure that code works as expected. I'm going to reload while sending the cookie, and it just says, now let me load it in a new thing. Just resent my thing. So I'm going to load a new browser, and it says no username, sorry. And however many times I do this, it will say no username, sorry. Cookies. It'll just keep saying no username, sorry, because we haven't processed it. But by me doing this, one step at a time, what this is showing you is that I'm just showing you what code is running the server. And this is, this looks like a long process, but when you're writing your web apps and debugging, you should definitely be doing this. So you should not be writing like 100 lines of code and running it and saying, oh, it didn't work, and then why didn't it work? Because you'll never find out why it didn't work. So you should, like at every step along the way, like I'm doing live, you should keep reloading your page and make sure that it's sane, because it will break some time on some weird error. So what this is doing is that it's saying no username, sorry, which means that this code is executing, which is good, because then we're going to start writing this code. So if we don't have a username, then we want to grab a cookie. So we want to see if we have a cookie now. Do we have a cookie? This is the exact same code. I'm just copy and pasting it. And then I'm just going to copy and paste this code right here. Oh, this looks really ugly to copy and paste. Better off just writing it, but let's, so go up. And we're here. So if there's no cookie, then we just print, sorry, you don't have what is this? Sorry, you're not logged in. Sorry, you don't have a username and you're not logged in. And then we're done. Whoops. And then else, we're going to do something. We're going to do something good. Let's not do anything yet. Okay, so this is the case where you don't have a cookie at all, where you don't pass in a username and you don't even have a cookie. So we want to just make sure that works. So this is like the complete loser case where someone just tries to visit your site and nothing happens. Okay, so this basically is the equivalent of visiting Facebook without a login, right? You just go to facebook.com, it just says, here's the homepage, go create an account, and like give us all your personal info. So there's no matter how many times I visit here, I don't have a cookie yet. So the server just simply says, hey, you're out of luck, and you can print a pretty picture or whatever. But this is the case we really care about. This is I actually have a cookie from you now. So I'm going to do something with it. So the thing I'm going to do, this is exact, you can study this offline, this is the exact same code as before. I'm going to grab the cookie, parse it. I can just erase all the bottom. I can parse it and print a beautiful profile here. Now I'm just going to print, you are logged in as, what is it, C current name? I know with a C prompt, that's fine. Value. Okay, so at the end of all this, what you see is if I have a cookie, I'm going to execute this code. And I hope this actually runs right. So this is our terrible looking version of Facebook. So the first time we need to give it a username, right? Our first time to Facebook or whatever, my name. Great. So it says, oh, good. You're in. You have a cookie right here. Now when I go to the site again, I can go to it. Let me go to it in another browser window just to clear everything out. When I go to it again, I don't have a, I don't pass in a username, but I do have a cookie, right? So now it says I'm logged in, which is good, right? Notice how this URL says nothing about Philip, nothing about anything. This is just like my homepage. And no matter how many times I reload, it says I'm actually logged in. And I can go to another window. That's my Google thing. Another window, I'm logged in. So it's like if you're logged into Facebook, no matter how many windows you open in your browser, you're still logged into Facebook, all right? So this is it. Well, I'll display the picture in a bit, but this is basically what you need to have a login because you have everything. Yes?
So would that also mean that when you, for some reason, hit log out on Facebook, that's a fancy way of deleting?
That's right. That's right. That's exactly right. So in order, if you want to log out, this is our awesome functionality. Now, yep, you can delete the cookie. So if I delete the cookie here, and I go to the same page, I'm back at the loser page. Yep, so exactly right. So logging out deletes your cookie. And this is also the, when you close your browser, your cookie might get deleted or might not, depending on it's persisting.
After you log in, if you add another name to the browser, what will happen?
Yeah, what would happen? So I am, so let me, I'm gonna log in, I have my cookie, I'm here, I'm logged in as Philip. So if I actually add a name, let's just say I set my name to John, that's my name, let's do that. What do you think will happen? Yeah, override it. So yes, this is a terribly designed site. It'll actually think I'm John now and log in as John. And if I go back, and it's because that's all the code that's, and now I'm John. Great, I'm John. This is why security is really hard to make, right? I mean, this is clearly not a secure site. But it only does whatever the server says. And it just goes to this code right here, and it just throws me a new cookie. And the point that this question brings out is, if you send another cookie with the same key, it will override it in the browser. So it will override it. Yes?
So this will just keep thinking you're the same person every time you refresh until you take your name out?
No. You mean if I put John or no John?
Like if you're, so every time you refresh, they'll keep thinking you're John until you either,
It'll keep thinking I'm John. I don't have to say John. And the reason why I don't have to say John is that my cookie here, this doesn't reload, but my cookie here is John. So every time I visit this web page, it will, the picture here that's relevant here, we can go over this in office hours tomorrow too, is the relevant picture is every time I visit, I'm sending my cookie to the server so it knows that I'm John. And the only way to get rid of it is to delete the cookie. Yeah.
It really can be signed in with, like John and Phil at the same time.
Not in this current way, because I only have one my name field, right? So you can be if you have a separate browser. So if I started Internet Explorer and did that, it's a completely separate browser. So each browser stores its own cookie. So you can be John in one browser and Philip in another one, but not in this code. You can't be both. All right, so we have 1 or 2 minutes left, and I'll just fill out the rest of the code. And so magically, I'm just going to copy and paste the code here, which is not great form, but let's just do it anyways. So if you actually do this for real, you should write a function. So this, recall, was the code to get my profile out of the database. So we did this for the first call, right? So the first time you visit, we printed this pretty profile, right? Ooh, cat picture and everything. And that was this code, because we grabbed Philip from the database and printed it. So I'm just going to do what you all want to do is just copy and paste. I'm just going to copy and paste this in. I am here. Down here, I'm going to copy and paste this in, fix the terrible tabbing. And now, instead of name, well, let's just say name. Let's just make a variable. It's always good to make variables so you don't confuse yourself, but let's just call this name equals that. I just assigned it to variable. You're logged in as name. I'm going to print a HR, which is a vertical bar, just horizontal bar, just to separate it. And then what I do is I do the same database lookup with name. You need this in a list because this expects a list of parameters and not one. It's just annoying. But now what it should do is it should grab the name from the cookie, and then it should look it up in the database and show your profile. So first time, let's do this again. First time, I am Philip. I'm in. And now I'm going to go here, right? There's no Philip here anywhere. There's nothing anywhere. And I'm actually logged in, and it actually pulls my information. So I am logged into my terrible Facebook. However many tabs I open, it's good. I am logged in. I don't have to say my name ever again here. If I go to Internet Explorer, my first time opening this ever. Just get like a Microsoft ad here. What happens if I go to Internet Explorer? No username. You're not logged in because the cookie is per browser. So if you use Chrome, if you have like different profiles, that's basically isolating you. So you can like have one profile for, yes?
Create a session, so conceptually, what would be the difference between a session and a cookie?
I purposely, did I use the word session anywhere? I purposely avoided the word session. Oh, there's session cookies. Because the word session is super confusing. So let's not go into that unless we have to. Yeah, I call it a login session or something. But so before we end, let's just delete the cookie. So log out of Facebook. Yay. And I am logged out. Oh, set Philip again. So my name is John. So I'm going to log in as John. Wait, did my thing freeze? Right in time to class to end. I think the web server just froze. Don't know why, but I ran into Explorer. That's right. It like totally crashed my whole web server. What the heck? Anyways, the recap here is we basically managed to squint hard enough. You can make $1 billion website as well, right? We basically managed to do it so you can log in, and you don't need to put in your username every time. And that is basically the first module. So next time, remember to check Piazza if you haven't signed up yet, like all the announcements on there, and we'll start the next module. I'll be around for a little bit for questions and have office hours tomorrow. So see you all on Thursday.